Hi everyone, I wanted to talk to you a little bit today about finding a p-value for a t-test. I've had a couple of questions about it, so I figured I'd put together a little video to show you. So this is in section 10.3. It is 10.3 number 15 and my version of the problem. So it says in a study, researchers wanted to measure the effect of alcohol in the hippocampal region, the portion of the brain responsible for long-term memory storage in adolescence. The researchers randomly selected 22 adolescents with alcohol use disorders to determine whether the hippocampal volumes in alcoholic adolescents were less than the normal volume. So it gives us a normal volume of 8.94 centimeters cubed. That will be part of our hypothesis. An analysis of the sample data revealed that the volume is approximately normal with a mean of 8.13 and a standard deviation, sample standard deviation, this S is why we choose a t-test rather than a z-test, of 0.7 centimeters cubed. Conduct the appropriate test at the alpha of 0.05 level of significance. So if we go through this test, we are testing a mean. It has a mean value here listed as x bar. So we also have dealing with means here, also standard deviation is only associated with means. So our null hypothesis is always going to be equals, and then we equal it to whatever we're testing against. So 8.94 is what we're testing against and what we have it equal to. Now our alternate hypothesis is what we actually think may be true. So we want to know if it's actually less than that 8.94. Continuing on in the problem, we want to identify the t-test statistic. Now, MyStatLab gives you a little hint that you should be using t where it says t statistic. On the test itself, it'll just say test statistic, so you have to determine whether or not you're using S in a t-test, or if you have a sigma here and then you're using a z-test. So on your calculator, if you're using the TI 83, 84, or the new, very interesting looking 84 models, you will conduct this test by hitting the stat button, cruising over to tests, and the second option here is t-test. Now, if I am looking at this particular problem, I'm using stats. The difference between data and stats is data gives you individual data points that you have to put into your list, versus stats give you summary statistics like X bar and S. So I'm going to change that to stats, and then it gives me my mu sub 0. Mu sub 0 is the value that you're testing against, so 8.94 in this case. My X bar is equal to 8.13. My sample standard deviation, 0.7. My sample size N is 22. And I'm testing a less than test. So when I press calculate, what I get is my test statistic and p-value and all of those things. So we'll go through what to do with the p-value in a moment. From my display, my test statistic is negative 5.427. Round to 2 decimal places, 5.43. Now it's asking me to approximate the p-value. Now, there are two different ways to do this. Your calculator is going to give you an exact p-value. So that exact p-value, you can decide which one of these ranges it occurs in. So what it gives me is 1.110 e to the negative 5. Now, what e to the negative 5 means is that I have to slide my decimal point over 5 units. So to give you an idea of what that actually is, my calculator is displaying 1.110 and then e negative 5. Now Excel is not going to put this into the right notation, but what that actually does is you have to slide the decimal point over 5 units in the negative direction. So that is really like 0.000110 for your actual p-value there. Now, once you get your p-value, we're going to determine the range. So this is the one that fits here is that it's less than 0.01 because it's 0.0000. So here we have less than 0.001 for our p-value. Now, the other way to determine a p-value is to use the t-table. So I have a picture of what table comes up when you press this button here for my stat lab. I'll actually be providing this table and another t-table for the final exam. Now, if I have 22 adolescents, then the degrees of freedom are always n minus 1, or 21. So I'm looking at the row, and you should be able to see my mouse over here. I'm looking at the row that corresponds with 21 degrees of freedom. Now, whatever test statistic I calculated, I have negative 5.43. I'm going to look for the absolute value of that, and I'm going to try and place it between two rows or two columns in my table. So if I look at this, 0.21 or 21, 5 point something is way over here. Since it's way over here on the table, if I look at the top, that means my p-value is less than 0.0005. So my p-value is less than that amount. I still have to choose whatever fits over here. So this one's less than 0.01, and based on our particular table here. Now, if we had calculated, say, 1.43, negative 1.43, then following that across, that would have occurred right here, which means that my p-value would be between 0.05 and 0.10. So this is how I use the table. So frame it between two columns, follow those columns to the top, 0.05, 0.10, that's what your p-value is between. Now, if you have a two-tailed test, so we're testing equals versus not equals, then we double all these values. So if I had a two-tailed test, then it would be between 0.1 and 0.2 because I multiply these p-values by 2. Moving on to a conclusion. Conclusions are always made the same way, regardless of what type of test you're making. You're making a comparison between the alpha value, 0.05, and the p-value that you've calculated here. So the rule of conclusions is, if the p-value you calculate is less than alpha, so if this p-value is less than 0.05, then we reject the null hypothesis. So p less than alpha we reject. If p is greater than alpha, we fail to reject. So anytime we reject, we do have evidence. So rejecting in statistics, it's almost like a good thing. We're proving with a margin of error that whatever this is, we're assuming is true. So there is sufficient evidence to claim that the volume is less than, this is what we're testing, 8.94. So this statement, your conclusion, is always based on your alternate hypothesis. So if you reject, you're rejecting your null, you're saying this is not true, therefore you have evidence of this piece. The values from that piece come right from it. Now, if you fail to reject, then there's not sufficient evidence. So failing to means no. Rejecting means yes, you do have evidence. All right, please let me know if you have any further questions. When you're going through Chapter 11, the difference between Chapter 10 and Chapter 11 is now you're going to be comparing one value to another value. Instead of, will be like mu1 equal to mu2 here, instead of mu equal to a value. So that is, conceptually, they're very much the same. We're just dealing with two samples now instead of one.